Hello everyone. Previous lecture we see some important example related with the inverse of matrix by elementary transformations. Okay, in that we consider row transformation and column transformation. That is, we perform the series of transformation to find the inverse of matrix. Now in today's lecture we go with the concept here, inverse by adjoint method. This is another method to find the inverse. Okay, very interesting concept it is. Before go with this concept, here we define minor of an element of determinant. Okay, here minor of an element of determinant. Okay, to define this concept, here we consider one element. Let Aij is the given element from the determinant. Okay, this Aij is in ith row and in jth column. Since here Ij is given, okay, here to find the minor of the element, minor of an element, here we delete ith row and jth column from the determinant to find the minor. Okay, here the minor of given element Aij is denoted by, here it is denoted by using notation capital M of Ij. So this is the notation for minor of the element here Aij. Let us consider one example to define the minor. Okay, let here given determinant is having element here 1, 2, then 3, 4. We have to find a minor of each element. Here we have to find minor of each element. Okay, here we know this is in the form here A11. That is here elements from the determinant are A11, A12, A21, then A22. Okay, let's find minor. Let us consider our first element. Here A11. Here first element is A11 and is, if we compare these, here A11 is 1. Now here A11 is in first row and is in first column. That is, this one is in first row and in first column. So we delete our first row and first column to find the minor. If we delete first row and this first column, here we get 4 only. So minor of 1, 1 is equal to 4. Then we find minor of next element. Here A12 is equal to 2. If we compare these two, here A12 is 2. Okay, here minor of A12 is denoted by using M of 1, 2. That is M12. Okay, here position for these two is in first row and is in second column. So we delete first row and second column to find the minor. Here only remains 3. So M of 1, 2 is equal to 3. Next, we find minor of the element A21. Okay, here A21 is having 3. So this is equal to 3. We know this 3 is in your second row and in first column. So we delete first, second row and first column to find minor. Okay, here minor is 2. Okay, so here M of 21 is equal to 2. Then minor for the last element, here last element is A22 and is here 4. We know here notation for the minor is M22. This is equal to find the minor, we consider the position of 4. We know this is in second row and in second column. So to find the minor, we delete second row and second column. Here only remains 1. So M of 22 is equal to 1. So by using this concept, we find the minor of each element of determinant. So remember this. We consider one example for this. Let's go with our next definition of this chapter, and is cofactor of an element of determinant. Okay, here cofactor of an element of determinant. Okay, again, to define this concept, here we consider one element. Let A of ij is the given element from the determinant. Here cofactor of this element is denoted by using here A of ij, that is Aij. So Aij is for cofactor of an element. Okay, here to define this we consider formula here -1 raised to I plus j. Remember, we consider -1 raised to I plus j. Here I is for row and j is for column, into here minor of that element, that is minor of here ij. Here minor of ij, and by using this formula we find cofactor of the element Aij. So remember this. Let us consider one example to define this concept. Okay, here we consider determinant having order 2, that is 1, 2, 3, 4. Here we consider 2 rows and 2 columns. Okay, before go with the cofactors of each element, we have to find minor of each element. Okay, here first element is A of 1, 1. Here A of 1, 1 is 1. Then we find minor of that element, M of 1, 1. We know position for this 1 is in first row and is in first column. So we delete first row and the first column. Here only remains 4. So M of 1, 1 is equal to 4. Okay, now by using this we find cofactor of A11. Here cofactor of A11 is denoted by using capital A of 1, 1. This is equal to define this we have a formula here -1 raised to I plus j into minor of that element. Here again we consider -1 raised to, here given 1, 1 means this element is in first row and in first column. So here 1 plus 1 into here minor of that element, that is minor of 1, 1. Now this is equal to here -1 square into, we know M of 1, 1 is 4. So we replace this by using 4. We know -1 square is 1. So 1 into 4, and we know this is 4. We know this is 4. So cofactor of A11 is 4. Similarly, we find cofactor of each element, remaining elements. Let's go with second element. Okay, here second element is A12, and this is equal to, here given 2. Okay, so here 2. Then minor for this element is M of 1, 2 is equal to, we know this 2 is in first row and is in second column. So we delete first row and second column. Here only remains 3. So this is equal to 3. M of 1, 2 is 3. Let's find cofactor of A12. Here it is denoted by A of capital A of 1, 2 is equal to, then here -1 raised to, here position for given element is in first row and second column. So 1 plus 2 into here minor of 1, 2 is equal to, here remains -1 cube into, here minor is 3. This is equal to, next here -1 cube is -1 into 3, and this is equal to -3. This is for second element. Similarly, here for third and fourth we find cofactor of element. Okay, so remember this. We see this example to define the cofactor of an element. In the similar way, we find cofactor of 3 and cofactor of 4. So remember this. Okay, now we go with our next concept. Here, adjoint of matrix. Adjoint of matrix. Adjoint of matrix. Adjoint of given matrix is denoted by here ADJ of A. This is for adjoint of matrix A. Okay, and to define this, we consider the cofactor matrix. Now we know what is cofactor of determinant. Okay, here we denote cofactors by using capital A of ij. Here A of ij. We consider each element of Aij to define the adjoint of A. We consider the transpose of cofactor matrix. Transpose of cofactor matrix. Let here Aij here having order m by n. Okay, this is cofactor matrix. This is cofactor matrix. Then here adjoint of A is transpose of this cofactor matrix. That is here Aij having order m by n and its transpose. So by using this we find adjoint of A. Okay, let us see one example to define the adjoint of A. Okay, here we consider one cofactor matrix. Let here Aij having order 2 by 2 is equal to, this is the cofactor matrix having elements here A11, A12, then A21, next is A22. Okay, so to find the adjoint we consider transpose of this matrix. Therefore here transpose of this matrix is denoted by using here Aij raised to t. This is for transpose. This is equal to, then in the matrix we convert first row in first column, second row for second column. Now here in first row given A11 and A12. So we consider that element for the column here A11, A12. That is, we replace our first column by using the elements of first row. Then for second column, to define the second column, we consider elements of the second row and here given A21, A22. So this is the transpose of given matrix. Okay, therefore here adjoint of A is equal to here matrix having Aij transpose and is equal to here in the matrix having elements A11, A21, A12, then A22, and this is the adjoint of A. This is the adjoint of A. So remember this concept. So by using minor, cofactor and the adjoint method, we find the inverse of given matrix, that is by adjoint method. Okay, before go with the concept of inverse of matrix by adjoint method, let us see some examples depending on minors, cofactor and adjoint of matrix. Okay, here given example is find the matrix of cofactors. Find the matrix of cofactors for the following matrix. For the following matrix given in first, here 1, 3, 4, 1. Okay, we have to find the cofactor matrix, and to find the cofactor matrix, firstly we find minor of each element. Okay, here given elements, or we consider this matrix as A. Consider here A is equal to matrix having elements 1, 3, 4, 1. We know here elements are here A1, 1, A1, 2, then A2, 1, then A2, 2. Okay. Here A11 is, here A11 is equal to, here position for this A11 is 1. Okay. So A11 is equal to 1. Let's find minor of this A11. It is denoted by using M of 1, 1 is equal to find the minor, we delete our first row and first column. So here only remains 1. Okay. Then to find the cofactor of that element, here it is denoted by A of 1, 1 is equal to, it is denoted, or here to find the cofactor we use minus 1 raised to. Here 1, 1 is given, so 1 plus 1 into minor of 1, 1, that is M of 1, 1. This is equal to here minus 1 square into, here M of 1, 1 is 1, so into 1. This is equal to, here minus 1 square is 1 into 1, and lastly we get 1. This is the cofactor of A11. Next, here we find, so we consider second element and is A12. This A12 is 3. Okay. Let's find minor for this element. It is denoted by using M12 is equal to, here this element is in first row and in second column. So we delete first row and second column. Here only remains 4. Okay. So M of 1, 2 is 4. Next, here cofactor for this element, here denoted by using A of 1, 2, that is A12. And to define this, we consider minus 1 raised to 1 plus 2 into M of 1, 2. Okay, this is equal to, here minus 1 cube into M of 1, 2 is 4. So 4 is equal to, we know minus 1 cube is minus 1 into 4, and lastly we get minus 4. Lastly we get minus 4. Similarly, we find the minor for the A21. Here element is A21 is equal to, okay, A21 is 4. A21 is 4. Then here minor for this element is M21 is equal to, we know this element is in second row and in first column. Okay, so we delete second row and first column. Here only remains 3. Now to find the cofactor for the given element, here we use A21 is equal to minus 1 raised to 2 plus 1 into M21. This is equal to, here minus 1 cube into M21 is 3. Again we know minus 1 cube is minus 1 into 3, and lastly we get minus 3. Okay. Then for last, here A22 is equal to 1. Let's find minor. M of M22 is equal to, we know this 1 is in second row and in second column. So we delete second row, second column to find the minor, and here minor is 1. Okay. Let's find A22, that is cofactor of A22, and is here minus 1 raised to 2 plus 2 into, here minor is 1. is equal to minus 1 raised to 4 into 1. And this is equal to, here minus 1 raised to 4 is 1 into 1, and this is equal to 1. So we find here cofactor of each element. We find cofactor of each element. Now we have to consider the cofactor matrix. Here cofactor matrix is like therefore cofactor matrix is equal to, is having elements A11, A12, A21, A22, and this is equal to, now we find A11. Here A11 is 1, so we replace A11 by using 1. Then A12 is minus 4, we replace by using minus 4. Then A21 is minus 3, and in last here A22 is 1. So this is the cofactor matrix. We find the cofactor matrix of a given matrix. Okay, so remember this example. Let's go with second example. Okay, here again we have to find the cofactor matrix. Here given matrix is A and is equal to, having in first row 1, 0, 2, then for second minus 2, 1, 3, then for last row 0, 3, minus 5. Okay, we have to find the cofactor matrix of given matrix. Now here we know this is in the form, this matrix is in the form here A11, A12, A13, then A21, here A22, then A23, then for last row here A31, A32, A33. Okay, our elements are like this. Okay, we consider each element to define the cofactor matrix. Okay, here first is A11. We know this first element is 1. Firstly we find minor of this element, and to find this we consider or we delete first row and first column. After deleting this we get the determinant. Here determinant is like this, m of 1 1 is equal to, now everyone check this, here m of 1 1 is having elements 1 3 3 minus 5. Remember here we delete first row and first column to define this minor, and we consider remaining elements in determinant. Now this is equal to, we know how to calculate this type of determinant. Here we get minus 5 minus 9. We know minus 5 minus 9 is minus 14, and this is the minor. Now we find the adjoint of the given element. Okay, it is denoted by using A of 1 1. This is equal to find the adjoint we consider minus 1 raised to, here 1 1 is given, so 1 plus 1 into minor of that element, and is minus 14 is equal to, we know minus 1 square is 1, and 1 into minus 14 is minus 14. Next here second element is A12. This is equal to, this element is 0. Okay, this 0 is in first row and in second column. Now so we delete first row and second column, and we consider remaining elements for the determinant. So in determinant we have elements minus 2, 3, 0, minus 5. This is equal to, we know here minus 2 into minus 5 is 10, and 3 into 0 is 0, so we have only 10. Then here cofactor for this element is A12 is equal to minus 1 raised to 1 plus 2 into minor of that element and is 10 and is equal to. We know minus 1 cube is minus 1. Minus 1 into 10 is minus 10. Next, here element is A13 is equal to, here A13 is 2. So this is equal to 2. Then minor for that element is AM of M13 is equal to, we know this element is in first row and in third column. So we delete first row, third column and we consider remaining elements for determinant. Here in determinant, we consider minus 2, 1, 0, 3. Okay, this is equal to, we know minus 2 into 3 is minus 6. Then 1 into 0 is 0. So we have only minus 6. Then here adjoint, cofactor of A13 is capital A13 is equal to, here we have formula minus 1 raised to 13 is given, so 1 plus 3 into minor is minus 6. Now we know minus 1 raised to 4 is plus 1. Plus 1 into minus 6 is minus 6. Is minus 6. Next element is A21 is equal to, here A21 is minus 2, so minus 2. Then here minor is M21 is equal to, we know this element is in second row and in first column. So we delete second row, first column and we consider remaining elements in determinant. So 0, 2, 3, minus 5. This is equal to, here we know 0 into minus 5 is 0, minus 6 and we get minus 6. Let's find its cofactor. Here cofactor is A21 is equal to, okay, here A21 is minus 1 raised to 2 plus 1 into minor is a minus 6 and this is equal to, we know minus 1 cube is minus 1, then minus 1 into minus 6 is plus 6. Then for next element A22 is equal to, here A22 is 1, then its minor is M22 is equal to, here M22 is in second row, second column. We delete second row, second column and we consider remaining elements in determinant. So in determinant 1, 2, 0, minus 5. Okay, this 1, 2, 0, minus 5 and this is equal to, we know 1 into minus 5 is minus 5, with minus sign 0 into 2 is 0. So we have only minus 5. Next, here its cofactor is A22 is equal to, here minus 1 raised to 2 plus 2 into minor is a minus 5. Okay, this is equal to, again we know minus 1 raised to 4 is plus 1 and 1 into minus 5 is minus 5. Okay, then we go with next elements. Here in next, given A23 is equal to, A23 is 3, okay, so here 3, then we know its minor is M23 is equal to, here M23 is in second row and in last column, that is in third column. Then we delete second row, last column and we consider remaining elements for determinant. Here in determinant we consider 1, 0, 0, 3. 1, 0, 0, 3. Okay, 1, 0, 0, 3. Okay, and this is equal to, we know 1 into 3 is 3. Okay, and 3 minus 0 into 0 is 0. So we have only 3. Then we find its cofactor. Here A23 is equal to minus 1 raised to 2 plus 3 into, here minor is 3, okay, and this is equal to, we know minus 1 raised to 5 is minus 1 and minus 1 into 3 is minus 3. Then we go with next element. Here A31 is equal to, we know here A31 is 0. We know its minor is M31 is equal to, we know position of this A31 and is in third row and in first column. We delete third row and first column and we consider remaining elements in determinant. So here in determinant 0, 2, 1, 3 and this is equal to, here we know 0 into 3 is 0, with minus sign 1 into 2 is 2, so minus 2. Next, here cofactor is A31 is equal to, okay, we consider minus 1 raised to 3 plus 1 into minor. Here minor is minus 2 and this is equal to, here minus 1 raised to 4 is plus 1. So 1 into minus 2 is here minus 2. Next, here A32 is equal to, here A32 is 3. Okay, so this is equal to 3. Then here its minor M32 is equal to, again we know position of this A32, that is this 3 is in third row and in second column. We did third row and second column आणि या ठिकाणी राहील फक्त inside the determinant 1, 2, minus 2, 3. 1, 2, minus 2, 3 and this is equal to, we know 1 into 3 is 3 with minus sign, minus 2 into 2 is a minus 4 and this is equal to 7. This is equal to 7. Let's find its cofactor. Here A32 is equal to minus 1 raised to 3 plus 2 into, here minor is 7 and this is equal to, we know minus 1 raised to 5 is minus 1 and minus 1 into 7 is minus 7. And for last, here A33 is equal to, here A33 is minus 5. Okay, here its minor is M33 is equal to, here we delete third row and third column and we consider remaining elements in determinant. So inside the determinant we have 1, 0, minus 2, 1 and this is equal to, here 1 into 1 is 1 with minus sign, here minus 2 into 0 is 0 and this is equal to 1. Next, here we find its cofactor. A33 is equal to, here minus 1 raised to 3 plus 3 into, here minor is 1 and we know minus 1 raised to 6 is plus 1, 1 into 1 is 1. So we find elements, all the cofactor of each element. Cofactor of each element. Now we define the cofactor matrix. Okay, so here cofactor matrix is equal to, is having elements here A11, A12, A13, then A21, A22, A23 and in last row here A31, A32, A33. Okay, we consider elements cofactor of each element. Here inside the matrix, here A11 is minus 14, then A12 is minus 10. Next, here A13 is minus 6. Next, A21 is 6. Then A22 is minus 5. Then here A23 is minus 3. Next, here A31 is minus 2. Then A32 is minus 7. And in last, here 1. So this is the cofactor matrix. We consider two examples to define the cofactor matrix. Okay, so very simple example it is. Now we go with one example to find the adjoint of matrix. Okay, we consider one example of order 2, that is 2 by 2. Example here given, find the adjoint of the following matrix. Find the adjoint of following matrix. Okay, here given matrix is having elements 2, -3, 3, 5. Okay, here we consider this matrix as A first. Consider here A, and this A is equal to matrix having elements 2, -3, 3, 5. We know here this is in the form the matrix having elements A11, A12, A21, A22. Okay, here we consider minor of each element and cofactor of each element. That is, we find the cofactor matrix to find the adjoint. Okay, here A11 is equal to 2. Here 2 is in first row and in first column. We delete first row and first column. Here we get only 5. So M of 1 is equal to 5. Let's find its cofactor. Here its cofactor is A11 and is equal to here -1 raised to 1 plus 1 into minor. Here minor is 5. We know -1 square is 1 and 1 into 5 is 5. Okay, let's go with second element. Here second is A12. Here A12 is -3. Okay, here -3, then its minor is M12 is equal to, here this -3 is in first row second column, so we delete first row second column. Here only remains 3. Okay, then A12 is equal to, here -1 raised to 1 plus 2 into minor is 3. We know -1 cube is -1 and -1 into 3 is -3. Next element is A21 is equal to, A21 is 3. Okay, then its minor is M21 is equal to, we know this 3 is in second row first column, so we delete second row first column. Here only remains -3. Okay, then its cofactor is A21 is equal to -1 raised to 2 plus 1 into minor. Here minor is -3, and lastly we get here -1 cube. We know this is -1, -1 into -3 is +3. And in last, here A22 is equal to, A22 is 5. Okay, this 5 is in second row second column, so we delete second row second column. Here only remains 2, so M22 is equal to 2. This is the minor. Next, here adjoint, cofactor of 22 is equal to, here -1 raised to 2 plus 2 into minor is 2, and this is equal to, here -1 raised to 4 is 1 into 2 is 2 only. So we find minor and cofactor of each element. Now we consider the cofactor matrix. Okay, here therefore cofactor matrix is equal to, okay, we denote this by using A of ij, okay, having order 2 by 2, and this is equal to, okay, we consider each element, each cofactor. Okay, here first is 5, second is -3. Okay, then A21 is 3, next A22 is 2. So this is the cofactor matrix. Now we know to find the adjoint we consider transpose of this matrix. Okay, therefore here Aij having order 2 by 2 and its transpose is equal to here inside the matrix. Okay, here we convert our first row to first column. So this 5 minus 3 is in first column. Then for second row, here we consider second row, we consider this second row for second column. That is this 3, 2. So this is the transpose of cofactor. Therefore, the adjoint of A is equal to Aij and its transpose having order 2 by 2 and is equal to the matrix having elements 5, 3, minus 3, 2. So, we find adjoint matrix of given matrix. And for this we consider minors and cofactors. So we see one example for this adjoint of matrix. Now in next lecture, we find the inverse by using method of adjoint. That is, we consider this adjoint matrix to find the inverse. Okay, so thank you.